So this notes kind of follows after that video of all the different types of substances and the conductivity, and you should have noticed, that some of them conduct really well, some don't at all, and then some were kind of okay-ish. And if that probably reminds you of when we talked about the difference between covalent and ionic compounds. That was a while ago, but we're going to get into way more detail now. So, why didn't the barium sulfate, which is an ionic compound, so from what we learned before, it should conduct, and why didn't the sugar conduct? And why did the vinegar only slightly conduct? So I'm going to show you guys a PHET, and the PHET gives us a microscopic view. So let's do a macro view of salt, and let's move my picture, and I'm gonna just start shaking the salt in. So you can see that I'm conducting and it's getting brighter and brighter the more I add. It reaches a point where the solution's saturated, and no matter how much salt I add, it's not going to conduct any better. But I think if I show you the microscopic view of the salt, you'll remember that the reason why it's conducting is because when you put it in water, it breaks into the sodium, the positive ions, and chloride, the negative ions, which are going to be attracted to the oppositely charged electrodes of the conductivity meter. So then I can show you the sugar. So sugar, and I should get I don't know why that thing's lighting. So the sugar, and then I bring over my meter. Uh-oh. It shouldn't be doing that. I think it's because I didn't reset. Oh, I have the salt on there still. Okay, let me do it again. Sugar in the water, conductivity, no. And then if we look at a microscopic level, the reason why is because when I add these sugars, they're not breaking into ions. So I'm not getting any, positive and negative ions. So let me put that away. So what we're talking about today then are electrolytes, and we have electrolytes in our body. They're really important that we have the right amounts of different ions for so much of how our muscles work and how our neurons transmit. It's a huge part of physiology. And you guys know that sometimes if it's really hot and humid, you might or if you've had stomach flu, you drink Gatorade or Pedialyte because it replenishes those electrolytes. So there are 3 different terms that we're going to talk about. Strong electrolyte is when the light bulb is really bright, and this is because the compound is going to break up into ions pretty much 100%. So when I add the sodium chloride, it's going to be all sodium and chloride ions and no longer going to be that crystal. So that was why we would consider it a strong electrolyte. A weak electrolyte like vinegar, and I didn't show this on the PHET, but the guy demoed it for you. So vinegar is going to break up, but only a small amount of it will break up. So most of it stays together, but it has to break up into ions a little, otherwise you wouldn't have seen the light bulb light at all. And then that leads us to like a non-electrolyte, which would be like sugar. It's going to go into water. It might break, it's a disaccharide, it might break into 2, but that's still not giving any ions. So if there's no ions, it's not going to conduct, so it's a non-electrolyte. In this diagram here, I want to make it bigger. This is kind of showing you, HCl, that was another one that in the video when he demoed, it conducted very well because 100% of it breaks up, and we're going to talk more about that when we get into our acid and base unit. Whereas here, this is vinegar. So look at the yellow here. Those are the together vinegars, but then only a few of them broke apart and give you the red and the green. And then another example, this would be a non-electrolyte, I think. Actually, it is a weak electrolyte. This is a weak electrolyte too, because a very small amount of ammonia will break apart. So we won't focus on that yet. When we get to acids and bases, we can. So anyways, I hope that helps.